All right, let's begin this morning. We have worked at the beginning of the chapter. We worked on graphing these trig functions. We graph sine, we graph cosine, we graph tangent, then we shifted them left and right, we shifted them up and down. Now we're going to look at the information. A lot of times it means a graph, and we're going to write the equation for that information that's given to us, either points or a graph or some information about that equation. So, as we look at this, to begin, we're looking at sinusoids. And really, to be perfectly honest, we've been graphing sinusoids also, because sinusoids are the graphs of sine and cosine. So, sinusoids are the graphs of sine and cosine functions. The graphs of sine and cosine functions. Now, we should know at this point, that for a sine curve, that equation looks like y is equal to a sine of b times the quantity of x minus h plus k. And if it's cosine, that equation looks like y is equal to a cosine of b times x minus h plus k. Okay, now let's take a little stroll down memory lane here. What does a tell me about? Amplitude. What else does a tell me about? Okay, yep, it is that middle point for tangent. That's exactly right. What about for sine and cosine? Tells me the amplitude, and it also tells me if there's a reflection. Absolutely. What does b help me with? The period. And for sine and cosine, what is the period? 2 pi over the absolute value of b. Fantastic. What does the h do for me? The h value is a shift left to right, and the k value is a shift up and down. Absolutely. Okay, fantastic. Okay, so the amplitude, remember, is the absolute value of a. Amplitude is the absolute value of a, but I also want you to realize that there's another way to refer to amplitude, and I talked about this back when we graphed, but it never became an important component. So the amplitude is the absolute value of a, but it is also the absolute value of the maximum value, subtract the minimum value, divided by 2. Maximum minus the minimum divided by 2. All right. Then we decided that the period is 2 pi over the absolute value of b. Remember that b always has to be bigger than 0. My horizontal shift is the h, and my vertical shift is the k. All right, now we're going to be working today to model, to write the equations for these sine and cosine graphs, these sine and cosine waves. Okay, I'm going to give you a set of steps. I'm going to give you a little bit of a recipe of what we're looking for to get that done. Okay, so the steps are, first thing you want to do is we want to find the maximum and the minimum values on my graph. We want to find the maximum and the minimum values on that graph. Okay, second thing we need to do is we're going to find the k value. We're going to identify if there is a vertical shift. We're going to look to see, was this graph shifted up or down? Okay, and my k value, the vertical shift, is always the max plus the min divided by 2. Capital M in math is always the maximum value. The little m is representing the minimum value. So it's the maximum value plus the minimum value divided by 2. Now I got a comment for you. Isn't it true that my vertical shift goes through the middle of that wave? Does that make sense to you? Okay. My vertical shift is going to go through the middle of that wave. Well, the max plus the min divided by 2, that's the top plus the bottom divided by 2. What am I really doing here? I'm really finding the average of those values because I know it's going to go through the middle. Fantastic. So my vertical shift is the average of the maximum and the minimum values. Okay, The third thing that I want to do is I need to decide if my graph would better be represented as a sine graph, oops, or a cosine graph. Is it better represented with a sine graph or a cosine graph? Now, we need to think about those graphs for a minute. Where does sine intersect the y-axis? Okay, 0, 0, and really, isn't it true that it's in the middle of my graph, right? Sine intersects my graph at one of the x-intercepts. Is that fair enough? Okay. Where does cosine intersect my graph? Where? Yeah, it is when it is not shifted vertically, it's at the amplitude. But cosine always starts at the maximum value or the minimum if there's a reflection, right? So we're going to keep that in mind. If my graph crosses the y-axis in the middle of the graph at the x-intercept, it's going to best be represented as a sine graph. If my graph intersects the y-axis at its maximum value or at its minimum value, it's going to be better represented as a cosine graph. And then, last but not least, we're going to find the amplitude using the absolute value of A is equal to the max minus the min divided by 2. And we're going to calculate the period as 2 pi over the absolute value of B to help us find little a and little b. Because we know that when we're writing the equations for sine and cosine graphs, I need to have a number for a number for b, a number for h, and a number for k. Now, some of those numbers may be 0. So it may look like they're not there, but we know that they're represented by the number 0. Just like y equals mx plus b, I need a number for m, I need a number for b. Sometimes the m and or the b might be 0, but that's okay. We need a number for each of those pieces. Okay, so looking at this graph. All right, we're going to write the trigonometric functions for the following graph. All right, looking at this graph. Okay, so as I get started, the first thing I want to do is find my maximum value and my minimum value. Okay, so what is the maximum value on this graph? What is the maximum value on that graph? A 2. And what is the minimum value on that graph? A negative 2. Perfect. Okay. Now, that information helps me greatly because what do I do second? All right, I'm going to find that vertical shift. And the vertical shift, the k value, is equal to the maximum plus the minimum divided by 2. So if my maximum is 2 plus my minimum of negative 2 divided by 2, what is my k value? 0. Oh my gosh, does that make perfect sense? Look at this graph. Did it shift up or down at all? No, it's centered right there over the x-axis, over the horizontal line of y equals 0. That should make sense to us. Okay, now, the third thing I need to decide is this graph going to be a sine graph or would it be better written as a cosine graph? Cosine graph. Okay, why do you choose cosine? Okay, where is it crossing the y-axis? Where is the y-intercept of this graph? You got 3 choices. Is it at the maximum? Is it at the x-intercept? Or is it at the minimum? It's at the minimum value. My minimum value is where it's crossing the y-axis. If it crosses the y-axis as its minimum value, is it better with sine or with cosine? Cosine. Cosine is better when it's the max or the min. So it's going to be cosine. But now I got a question for you. Because it crosses at the minimum, because it crosses the y-axis at the minimum, is there anything else that we know about this equation? It's a reflection. which means what in my equation? The A has to be negative. If there's a reflection, I know that I need to represent it. My A has to be a negative value. My A has to be a negative value because there's a reflection. Okay, and my fourth piece, I need to first of all work to find my amplitude. The amplitude, the absolute value of A, is the absolute value of the maximum minus the minimum divided by 2. So the absolute value of my maximum of 2, subtract my minimum of negative 2, divided by 2. What is my A going to be? Let's see, 2 subtract negative 2 divided by 2 is 2, right? Because the absolute value of 4 divided by 2 is going to be 2. So, if the absolute value of my A is 2, what is the A now? The A, though, has to be a negative 2 because we know from above that there's going to be a reflection. Any questions so far? Any questions so far? All right, then we're going to go ahead and find the period. All right, the period is represented by 2 pi over the absolute value of B. Now, we need to figure out what is the period of this graph. What is the period of this graph? Okay, isn't it true? It starts here at the minimum, right? So the first cycle of this graph here, it starts at the minimum. It's going to go up to the x-intercept. It's going to go up to the max. It's going to go back to the x-intercept. It's going to go down to the minimum. And right here is where I am through my first cycle. I am back in the wave to exactly the same spot I started at. Does that make sense to you? Okay, now, when I was traveling through that cycle of cosine, from here to here was pi over 3, which means from here to here is going to be another pi over 3, which is 2 pi over 3. If I have a third of a pi to here and another third of a pi to there, that's going to be 2 pi over 3. So the period of this graph, because the first cycle ends right here, the period of this graph is 2 pi over 3. Now, what do I really want that for? Why do I care about that? Nobody does. I need to find the b. And what's my b going to be? All right. 2 pi in each numerator means my denominator, the b, has to be equal to 3. Okay, now, the most important reason for this is to be able to write an equation. Okay? So, y is equal to my a value of negative 2. We decided that it's most efficient with cosine, so cosine of my b value of 3 times x minus, did I do any shifting left and right? No, I didn't do any shifting left and right because my minimum was right on the y-axis. So then my k value, I didn't do any shifting up or down either, so there's no k value either. So here is the most efficient way to write that equation. Now, I got a question for you. Is it possible to write it with a sign? Will my amplitude be the same if this was a sine curve? Will my period be the same if this was a sine curve? Will the vertical shift be the same if it's a sine curve? So what will change? The horizontal shift, absolutely. If I wanted to represent this, and that's legal, it's not going to be as nice of an equation, but if I wanted to write this as a sine function instead, where would I have to start that sine function? Where would it start if it were a sine function? Pi over 6, right? Half of the way to pi over 3 would be right here, where I would start the sine curve. Does that make sense? At pi over 6, halfway to pi over 3. So if I wrote that equation, y is equal to my a, I got a question for you. Is my a going to be the same? Is a 2? Is the amplitude 2? Yes. Now, if I start with sine, is there a reflection? If I start sine right here, will there be a reflection? No, because it would start from this point and would go right to the maximum. That means that for sine, starting at pi over 6, my a value would be a positive 2. Sine of my b value is not going to change, so 3. Now we've shifted this though to the right pi over 6, so that's going to be x minus pi over 6. Does that make sense to everybody? So this is the most efficient way to write this, the easiest. But how many different ways could I write equations on here? Are these the only two ways? No, I mean I could start cosine right here at pi over 3. Start at the top with a positive a value. I could start cosine here. I could start sine here. There are infinitely many ways to write the equation of these sines and cosine waves. Now, I will be honest. This one right here is the best because it's the most efficient. It's the quickest one. But this isn't wrong. This is not wrong at all. I'm hoping that you do the most efficient one, the quickest one, which alleviates, in most cases, having to do a shift left or right. Does that make sense? And where do we make our mistakes when we were making our graphs? When we had to shift left or right. So what would be the most challenging thing, it would seem logical, when you're writing the equations? Shifting left and right. So try to do the most efficient method possible. All right, let's try another one. All right, number 2. Number 2, we're going to take a look at this one. All right, so first thing we need to do is find our maximum and our minimum values. All right, where is the maximum on this graph? Where is the maximum value on this graph? Okay, is it perfect? No, I would say it's probably, if I had to guess, it's probably 1.5. Now, if I give you a value that's a half on a quiz or a test, I promise you it will be blatantly obvious and it will be marked, okay? You're not going to have to guess. I kind of find this to be guessing on this one. But I would say that my max is 1.5. What about the minimum? What about my minimum value? We would estimate it to possibly be where? Negative 1.5. I would say that that's pretty close to negative 1.5. Okay, what are we going to do second? What are we going to do next? All right, we got to look at the vertical shift. Got to look at the vertical shift. So my k value is equal to the max plus the min divided by 2. So my maximum value of 1.5 plus my minimum value of negative 1.5 divided by 2 is 0. There is no vertical shift. It's not shifted up and down at all. That should seem very reasonable to us. Okay. What comes next? What comes next? All right, we've got to figure out, is this going to be a sine graph or a cosine graph? Is this going to be a sine graph or a cosine graph? No thoughts? Sine graph, why do you say that? All right, the y-intercept is at the origin. The y-intercept is at the origin. It starts at 0, 0. I would say that sine is a good choice. Now, is there anything else at that moment that I need to think about with the sine? Is there a reflection? Yes, my sine curve starts and it goes down to the minimum to start. So there is a reflection, so my A value has to be negative. My A value has to be negative because there is a reflection. All right, then, got to think about that amplitude. Okay, the absolute value of A is equal to the absolute value of the maximum subtract the minimum divided by 2. So the absolute value of my maximum of 1.5 subtract my minimum of negative 1.5 divided by 2. 1.5 subtract a negative 1.5 divided by 2 and then the absolute value. What do we get? 3/2. Very nice, very nice. 3/2. So what is my A value? My A value is going to be negative 3/2. All right. Then the period. The 2 pi over the absolute value of B. Now, in this case, what is the period of this graph? What is the period of this graph? 6, okay, because through one cycle, if we look through one cycle, from my x-intercept to my minimum, back to the x-intercept, to the maximum, back to the x-intercept, I travel a distance of 1, 2, 3, 4, 5, 6 units. So the period, 2 pi over the absolute value B, is equal to 6. What are we going to do? What are we going to do with that? Nothing? What are we going to do with that? All right, 6 over 1. Make it a proportion. So now we're going to cross multiply. So if 2 pi is equal to 6 absolute value of B, and I divide both sides by 6, what is B? Pi over 3. Very nice. Absolute value of B is pi over 3, so B is equal to pi over 3. All right. Now I'm ready to write my equation. So y is equal to my A value of negative 3/2 times, we decided it's going to be a sine graph of my B value pi over 3 times x, no shift left or right, no shift left or right, sine starts right away from the y-axis, and then no shift up or down because my k value is 0. So here's the most efficient way to write that wave. Is it the only way? No, but this is certainly the most efficient way to write that equation. All right, number 3. Number 3, looking at that graph, go ahead and find the equation of that one. Go ahead and find the equation of that one on your own. Now, just a comment, because I know on my sheet it looks nicer, but when you blow it up it looks sometimes a little bit off. But these are the maximum values and the minimum values. They're at nice integers. So don't think you have to, I mean, I can only do so well on the computer. So they are at nice integers. If you need some help, let me know. All right, one more minute, please. All right, are we ready? Okay, so where do we start? Where do we start? All right. What is my max? 10, and what's my minimum? 2. Yep. All right, so where do I go from there? What's the second thing I need to do? All right, I need to find out if there is a vertical shift. All right, and my K value, the vertical shift, is the maximum plus the minimum divided by 2. Okay, so my maximum's 10 plus my minimum of 2 divided by 2, which is 6. Okay, so my K value is 6. This is shifted up 6, which means the middle of my graph now should be at y equals 6. Well, if I go up to y equals 6 and I make that horizontal line, notice how that horizontal line at y equals 6 cuts that graph right in half. So that should make sense. My vertical shift of 6 up 6, now it cuts it in half at that horizontal line at 6. Okay, things are looking good. All right, now what? All right, is it going to be a sine or a cosine graph? What is the most efficient way to write this? As a sine or a cosine graph? Cosine graph, absolutely, because my graph starts at which value? It starts at my maximum value, okay? The y-intercept is at the maximum value, which means it's smarter to write it as a cosine graph. What kind of a value am I going to have? What kind of a value am I going to have? Positive, okay? So my a value is going to be positive. All right, then, fourth thing we have to do, look at that amplitude. The absolute value of a is equal to the absolute value of the max, subtract the min divided by 2. So the absolute value of my max 10, subtract min 2 divided by 2 is 4. All right, oh my gosh. Here I am at 6, and I go up to 10. Well, from 6 up to 10 is a distance of 4. From 6 down to 2 is a distance of 4 as well. My amplitude is 4. That should make sense. Half of the height of this graph is 4. Okay, so that a value, we already said my a is going to be positive, so the a is 4. Last but not least, the period of my graph is represented by 2 pi over the absolute value of b. What is the period of this graph? What? 4 pi. Okay, notice. Take a look here. From the beginning of my graph, from the max to where it crosses the middle, notice it's not an x-intercept anymore, where it crosses the middle, down to the minimum, back up to the middle, and then back to the max. Well, from the maximum to the middle, it was a distance of 2 pi. So from the minimum back to the max, I'm going to go another 2 pi, which is going to take me to 4 pi. So the period's 4 pi. And what do I get when I solve for b? All right, so if I cross multiply 4 pi, absolute value of b is equal to 2 pi, divide both sides by 4 pi, and the absolute value of b is equal to 1/2, so my b is 1/2. Oops, running out of space here. Okay, so I am ready to write the equation of this graph. So y is equal to, the a value is 4. Best to write it as a cosine. My b value is 1/2 of x. My maximum's on the y-intercept, so there's no shifting left or right. And then there's a vertical shift up 6. So it's going to be plus 6. Anybody have an issue with that? Any question with that? Any question with that? All right, then let's take a look at number 5. We're going to finish up with this one today, and then tomorrow we'll get out the graphers and work with those graphers tomorrow. All right, sinusoidal curve has a maximum value of 0.2 and a minimum value at 4, -4. Write an equation for this function. Okay, so got to draw a picture. No doubt about it, definitely need a picture. Definitely need a picture. Okay, so my maximum value is at 0.2. Okay, so I go up 2, and at 0.2, this is my maximum value on that graph. All right. Minimum value at 4, -4. So I go right 4 and down 4. And my minimum value here at 4, -4. Now, as I see that, what kind of graph are you seeing? I see those 2 points, and if I think about those 2 points going through a wave, what kind of graph should I be seeing? Cosine. Okay, here's from my maximum, and then it's going to slope down, I don't even know where, and it's going to go down to my minimum value, and then it's probably going to go back up, and down and back and around over there. I would agree, it definitely looks like it's probably going to be a cosine graph because it starts at the maximum value. But right now, I don't even need to concern myself with that. I, first of all, I'm going to walk myself through the steps. So my max is at 2. My minimum is at -4. All right, so I'm going to use that to find the vertical shift, if there is one. There isn't always going to be one. So my vertical shift, the k is equal to the max plus the min divided by 2. Well, my maximum value of 2 plus my minimum value of -4 divided by 2. Is there a vertical shift? Of what? -1. Okay? Now let's think about what that means. That means if I go down 1 to y equals -1, that should cut my graph in half here at y equals -1. Well, even as bad as my sketch is, that looks like it seems logical. Looks like it seems reasonable. Okay? Any problems so far? All right, so third thing, sine or cosine? Cosine, we decided that already. And then cosine, is my A positive or is my A negative? A is going to be positive because my y-intercept starts at the maximum value of this graph. And finally, we got the messy stuff left. All right, my amplitude, the absolute value of A is equal to the absolute value of my max. Subtract my min divided by 2. So the absolute value of my maximum of 2, subtract my minimum of a negative 4 divided by 2. What am I going to get for that A value? What am I going to get for my A value? 3. Beautiful. 6 divided by 2 is 3. So my A value is 3. Then the period, 2 pi over the absolute value of B. 2 pi over the absolute value of B. Well, 2 pi over the absolute value of B is going to be equal to, what is the period in this graph? 8. Absolutely. Taking a look. Fantastic. It took me from 0 to 4 to get halfway through that first cycle. So it's going to take me another 4 out to 8 here to get me back to the top, to the maximum once again. So it'll take me a horizontal distance of 8 to get through one full cycle of that cosine. So 2 pi over the absolute value of B is going to be equal to 8. I'm going to put 8 over 1. I'm going to cross multiply. 8 absolute value of B is equal to 2 pi. And what do we get for B? Pi over 4. Very nice. So B is equal to pi over 4. So my equation then becomes y is equal to my A value of 3. We decided that it's going to be cosine. My B value of pi over 4, x. No shifting left or right because my maximum starts right on the y-axis. And then a vertical shift down 1. So we're going to put minus 1. Questions with that one? Questions with that one? All right, tomorrow we're going to look at the last graphing calculator example.